There are two numerical summaries of data. First, the mean and standard deviation. The mean is the average, and the standard deviation is the spread or variability. We have different letters to represent parameters in statistics. A parameter is a number that describes a population, and a statistic is a number that describes a sample. The mean is mu and x bar. Typically, parameters are Greek characters. Just for clarity, mu is the mean of the population. We typically don't know this. X bar is the mean of whatever sample we collect. We'll know this. The standard deviations are sigma and s. Let's discuss how to draw sigma real quick. Start at the top, go left, around, up, and out. It just comes out looking better. There are formulas for both mean and standard deviation, but we won't use them. We'll be using some technology to compute all these numbers. The mean and standard deviation are great for describing symmetric distributions. However, they are not resistant to outliers, as we will see. The best way to see these is either a histogram or stem and leaf plot. A histogram looks almost like a bar graph, except the bars are touching. This bar is the percent of our data points between 5 and 6. This data is symmetric. The mean will be in the center, and one standard deviation on each side will have the same amount of data. A skewed distribution will look like this. This is skewed right. Think about taking your right hand and pushing the data over. The mean will be offset, and one standard deviation on each side will have different amounts of the data. The second type of numerical summary is the 5-number summary. This is min, Q1, median, Q3, and max. Q1 is the first quartile, and Q3 is the third quartile. In fact, the other numbers are also quartiles. Think about if we have 12 data points that look like this. We want to separate these into 4 parts so each part has a quarter of the data. In this case, each will have 3 data points. This is a box plot. Each bar in a box plot is one of the 5-number summary. Each region will contain 25% of the data. The middle range is the IQR. It's Q3 minus Q1. This is a useful number as it tells you how spread out the middle 50% of the data is. Suppose we had another data point way out here. How would this affect the box plot? If anything, it would pull the max farther out, but the rest remains largely unchanged. This is due to the median being resistant to outliers. Suppose we have a data set that has 6 tens and 10,000. The median is 10, the middle number. It would stay 10 even if 10,000 changed to 10 million. What happens to the mean though? Currently, the mean of this data is approximately 1,437. This doesn't represent any of the data. For this reason, we use the 5-number summary to determine when a dataset contains outliers. If any number is below Q1 minus 1.5 IQR or above Q3 plus 1.5 IQR, we say that point is an outlier.